Hi and welcome to today's class. So it is the 30th of March and it's class number 73. So we're going to start a new chapter today and we're going to look at how to solve quadratic equations. So we're going to look at how we can use factors to do that. So we're talking about quadratic. We met this word already last week. We're going to be talking about solving, which again we've already met, but this is going to be an extension of what we already know. We're going to meet these things called roots. We're going to deal with our factors, and we're going to use a very important property called the zero product property. So just to remind you, the word quadratic comes from the word quad, meaning square, because the variable gets squared, so x squared. But we could also say that it is degree 2, because the biggest power is 2. So we have two different graphs for quadratics. We have a positive graph and a negative graph. And I gave you this as well last week, the idea that positive people smile, negative people frown. So I'm going to link into the graphs a little bit here. So we haven't fully started into looking at quadratic graphs. However, for these answers, I'm going to try and explain to you what we're actually doing when we're solving a quadratic. So a quadratic equation is any equation that contains an x squared term. So if I said to you, can you solve this? Now this is a quadratic. We have an x squared minus 2x equals 0. Usually when we solve, we have something like this. 3x minus 2 equals 4. And our general rule is we get letters on the left over here and numbers on the right. So all the variable terms on one side, all the number terms some on the other side. So here we do vertical balancing. We add 2 to both sides. And when we do that, we get 3x equals 6. And then we divide both sides by 3 and we get a lovely answer. So if I said to you, well, can you do the same thing on this equation here? Well, have a think. Could we do the same thing? Well, all of our letters are on the left. All of those variable terms are already on the left hand side. And we're not going to be able to get it down to x equals because there are two terms that contain an x. There's an x squared term and an x term. So we're going to have to figure out a different way to work these because our traditional solving method, the vertical balancing method, is not going to be enough here. So just before we jump into actually solving it, I want to talk about what solving means. So solving a quadratic equation is a way to find the roots of a quadratic graph. So here are two quadratic graphs, and the roots are where the graph cuts the x-axis. So here are the roots of the positive quadratic and here are the roots of the negative quadratic. So we're always going to be looking for basically the x values where that happens. Now, like I said, that's not going to be very important for the moment. I will touch on it during the first few examples, but we will have a whole section on this next year. Because of the shape of a quadratic, this lovely curve, or parabola as it's called, we usually get two answers. So like the two examples here I've given you, one is positive, it gives me two answers, one is negative, it gives me two answers. Can you think of times where you could draw that curve and you wouldn't cross the x-axis twice? So if you've come up with some of those, you can let me know. So let's talk about the zero product property. So this is very straightforward. If I have A multiplied by B and I tell you that that product equals 0, then what do you know about A and B? So basically, can you think of two numbers that multiply to give me 0? So you can pause the video and have a think. So the answer is 0 by anything will give me 0. So this will be true as long as A or B is 0. So it has to be that either A or B is 0 or possibly both of them, possibly both. So this idea is called the zero product property. So we're going to use this to help us solve equations where we have already got our quadratic factorized. So I'm going to be really nice here. I'm going to give it to you in factored form. And then we'll go back to revising our factorization from last week. So let's take our first example. So example 1. solve x bracket x minus 8 equals 0. So this was something that has already had highest common factor applied to it. Okay, so we're not going to worry about that bit. They've done that bit for us. But we want to figure out, well, if I know this and it all equals 0, then how would I figure out two answers for x? And basically, the two things that are multiplied together, which are the first thing that's multiplied together is x, and it's multiplied by the bracket. So each one of those pieces is called a factor. So what we're saying is, by the zero product property, then we let each factor equal 0. So either x equals 0 or x minus 8 equals 0. Now, first answer is x equals 0. But what is our second answer if x minus 8 equals 0? So now we're back to having a linear equation that we need to solve. So we're going to go back to our vertical balancing and we're going to add 8 to both sides, and then we'll be left with x equals 8. So the solutions are x equals 0 and x equals 8. So what does that actually mean though? So let's go back to our quadratic curve for a second. And here's the graph. And it's telling us that when I draw the curve, it cuts the x-axis here where x is 0 and here where x is 8. Now I know there is no label on that, but if you look at each box being 1 unit and 3 boxes away from 5, that is 8. So x equals 0 is here, and this is x equals 8. So example 2. Here we're asked to solve x minus 2 times x plus 3. So this was originally a quadratic that we used a guide number to factorize. So again, by the zero product property, we know that either the first factor, x minus 2 equals 0, or the second factor, x plus 3 equals 0. Neither then give us a straight answer, so we're going to need to work it through. Let's work with x minus 2 first. So we're going to add 2 to both sides, and we get our answer as x equals 2. For x plus 3 equals 0, we're going to take away 3 from both sides, and we get x equals minus 3. So our solutions are x equals minus 3 and x equals 2. So again, what does that actually mean? What are we finding? And if we think about this in terms of our graph, we're finding 2 points. These are called the roots. And the first root is x equals minus 3. And the second root is x equals 2. So example 3. Solve 2x minus 5 times x plus 1. Again, this was a quadratic that guide number was used to factorize. We have two factors here, they're both in brackets, and they equal 0. So we know by the zero product property that either 2x minus 5 equals 0 or x plus 1 equals 0. So let's solve the first little linear equation. We'll add 5 to both sides, and that gives us 2x equals 5. And then we're going to divide both sides by 2, and that will give us x equals 5 over 2, or if you prefer, 2.5. So that is our first answer, and it's okay that it's a decimal. That's absolutely fine. Sometimes students think, oh, if it's not a whole number, it's incorrect. But it's not. That's absolutely valid. Second equation, we're taking away 1 from both sides, and we get x equals minus 1. So our solutions are x equals minus 1 and x equals 5 over 2. Or if you prefer, I find, and I'm not a big fan of decimals, I much prefer fractions. However, when we're talking about plotting them or talking about them in terms of our graph, it's much easier to understand in decimal than it is in an improper top-heavy fraction. Mixed fraction can be easier if you prefer, but I'm not a big fan of mixed fractions either. So what does this mean? So here is our graph. We have the first root here that is x equals minus 1, and this root here that is x equals 2.5, halfway between 2 and 3. So that just gives you a sense of how these relate to the graph and kind of what we're actually doing. So when we're asked to solve it, what are we actually finding? Now, we will do word problems, which mean that that x will stand for something in the same way that our linear equations, that x stood for something. But we'll get to that once we have perfected all of the techniques we need to solve our quadratics. So let's take a look at example 4. Now, solve this quadratic. I know it's a quadratic because it has an x squared term, but note, it's not a quadratic trinomial. So I need to go through the list of factorization techniques that I have. So the first one is highest common factor. So do these terms have something in common? And actually, you'll find that yes, they do. So x squared can be written as xx plus 5x, and that equals 0. So what's common is x, and that gives me x plus 5 equals 0. So now I have two factors. I have x and I have x plus 5. So using the zero product property, we can say that either x equals 0 or x plus 5 equals 0. Now, x equals 0 is lovely and easy because that's just answered. For x plus 5, we're going to have to actually solve for x, and we get x equals minus 5, and there are two answers. X equals 0 and x equals minus 5. It can be useful just to put a box around both answers so it's clear where my two answers are. Or like in our previous example, you can actually write them down again, the solutions are. But I'm a little bit lazy, so I'm just going to put box around them. So, example 5. So we have x squared minus 25 equals 0. Again, I have a quadratic, but it's not a quadratic trinomial. It has only got two terms. It's actually called a binomial. Bi for two. So think of the difference between your bicycle and your tricycle. So anyway, we need to factorize it, and in order to factorize it, we need to understand how to factorize it. So let's work through it. Highest common factor. Is there something common to both terms? And there's not. Okay. Second type of factorization we have is grouping. Now, we said initially when we did grouping that you needed at least 4 terms to do grouping. There's only 2, so it's definitely not grouping. Third one, quadratic trinomials. No, definitely not quadratic trinomials because there's not 3 pieces. So that only leaves me with one other thing it could be, and that is difference of 2 squares. And that is a difference of 2 squares because x can be written as x squared and 25 can be written as 5 squared. Difference of 2 squares, remember we open our 2 brackets. We put x at the start of each bracket, 5 at the end of each bracket, a plus in one bracket and a minus in the other. So then remember we have a zero product property which tells us that this factor multiplied by this factor equals 0. So therefore either x plus 5 equals 0 or x minus 5 equals 0. So now we need to solve those little linear equations. I'm going to subtract 5 from both sides here. And we get x equals minus 5. And here we do plus 5 to both sides. And we get x equals 5. And you'll notice that there's a lovely symmetry of our answers, and the reason is because we have this difference of 2 squares factorization. Because both brackets are the same with different signs, our two roots, so the two answers we get will be the same but different signs as well. So now you're going to try some yourself for homework. So question 1, there's 5 parts and these are already in factored form. What I mean by factored form is that they've already been factorized for you. You are welcome. In question 2, these are asking you to solve the quadratic equations, but these have not been factorized for you. Today I'm sticking with looking at highest common factor and difference of 2 squares. So question 2 will either be factorization using highest common factor or difference of 2 squares. Tomorrow we're going to revise factorization of quadratic trinomials using the guide number method. But for tonight, you can just focus on those two.